Look at this. Nothing. Complete darkness. But somewhere out there, one star is about to change everything. In 1783, a quiet English priest sat alone by candlelight. His name was John Michell. He picked up his pen and asked a question that shattered science. What if a star is so massive that light cannot escape? Everyone laughed. They called it madness. A dark star? Impossible. Light has no mass. Gravity can't touch it. For 100 years, the idea died, forgotten, buried under maps of a quiet solar system. Then came a man in a trench, World War I, artillery shaking the ground, Karl Schwarzschild, a German physicist. He read Einstein's new theory of relativity between battles. And he solved the unsolvable. His equations showed a point where space collapses to infinity. Time stops. Einstein refused to believe it. He stared at the math and called it a mathematical anomaly. Nature cannot be so cruel, he said. But Einstein was wrong. The equations were right. Deep in space, the universe already knew. A star dies. A monster is born. This is the story of the black hole. A star lives in balance. Gravity pulls everything inward. Nuclear fire pushes everything outward. For billions of years, this dance continues. But nothing lasts forever. The star burns through its fuel. Hydrogen becomes helium. Helium becomes carbon. Carbon becomes neon. Neon becomes oxygen. Oxygen becomes silicon. And finally, silicon becomes iron. When iron fills the core, the game is over. Iron does not burn. Iron does not create energy. The furnace goes cold. Without fire, gravity wins. The core collapses. In less than 1 second, a star much bigger than our sun crushes itself into a ball of nuclear matter the size of a city. The outer layers have nowhere to go. They fall inward at 1/4 of the speed of light. Then they hit the hard core, and they bounce. The explosion is called a supernova. For one brief moment, this single star shines brighter than an entire galaxy of 100 billion suns. But look closely at the center. The core is still there. It is no longer a star. It is something else, something new, something the universe has never seen before. Gravity pulls so hard now that even the atoms themselves collapse. Protons and electrons smash together and become neutrons. A neutron star is born, but this is not the end. If the core is heavy enough, not even neutrons can hold it up. Gravity continues to crush. Smaller, 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 past the size of a city, past the size of a mountain, past the size of a grain of sand. At this moment, something impossible happens inside. The mass of several suns is compressed into a single point, a point with no size, no volume, no surface, only mass, only gravity. This point is called a singularity. Around it, space bends so severely that it tears. A hole opens in the fabric of reality. This is the birth of a black hole. For the first time in the universe, there is a place where light cannot escape, a place where time stops, a place where nothing, not matter, not energy, not information, can ever return. A black hole has 4 parts. First, the singularity, the point at the center where all the mass is crushed into 0 volume. This is where physics dies. Second, the event horizon, the boundary of no return. Cross this line and you will never come back. Not even light is fast enough to escape. Third, the photon sphere. Just outside the event horizon, light itself gets trapped in orbit. Photons circle the black hole forever, neither falling in nor flying away. Fourth, the accretion disk. A swirling hurricane of gas and dust heated to millions of degrees. It glows brighter than 1,000 suns just before it disappears forever. If you fell toward a black hole, you would not feel anything at first. But as you got closer, gravity would pull your feet harder than your head. You would stretch like a piece of spaghetti. Time would slow down for you. From the outside, you would freeze at the event horizon. Your image would fade slowly. You would be gone but never seen leaving. Inside the event horizon, space and time swap roles. You cannot stop moving toward the singularity, just like you cannot stop moving into tomorrow. The future becomes a point of infinite density. No one knows what happens at the singularity. Some say space ends there. Others say a new universe begins. But one thing is certain. You would never come back to tell the story. If you watched from far away, you would never see someone fall in. They would slow down, fade, freeze at the horizon, forever stuck between here and gone. Time inside a black hole is not time anymore. The future points inward. You cannot turn back. You cannot stop. The singularity is not a place. It is a deadline. What happens at the singularity? No one knows. Mathematics breaks. Physics stops. Some say space ends there. Others say a new universe begins. But no one returns to tell the truth. One thing is certain. Black holes are not holes. They are the edge of reality, the place where our understanding of the universe dies, and that is why we cannot stop looking. In 2019, humanity finally saw the shadow of a black hole, not a simulation, not an artist's drawing, a real photograph. A network of telescopes spread across the entire planet, from Hawaii to Spain to the South Pole, all synchronized to capture the invisible. The image was blurry, an orange ring around perfect blackness, but it was real. It was the shadow of the black hole at the center of galaxy M87, 6.5 billion times the mass of our sun. 6.5 billion. That number is too big to understand, but the photograph does not lie. In 2022, they showed us another one, Sagittarius A star, the monster at the center of our own Milky Way galaxy, 4 million times the mass of the sun, only 26,000 light-years away. It has been watching us since humans first stood upright. Scientists hugged each other and cried. They had spent decades building telescopes, writing code, chasing a shadow, and they caught it. Newspapers around the world ran the same headline, "First image of a black hole. Finally, after all these years." But images do not answer questions. They create new ones. What happens to information inside a black hole? Does it disappear forever? In 2015, something else happened. LIGO detected gravitational waves, ripples in space-time from two black holes colliding 1 billion light-years away. The signal lasted less than 1 second, but it proved that black holes are not silent. They scream, and their scream bends the universe itself. When two black holes merge, space-time rings like a bell. For a brief moment, they release more energy than all the stars in the observable universe combined. Black holes are not evil. They do not hunt. They simply exist, and their existence changes everything we thought we knew. The size of a black hole is impossible to understand. A human silhouette next to that darkness. One tiny life against a billion suns. The information paradox. Stephen Hawking's greatest puzzle. Information falls into a black hole. Does it vanish forever or slowly leak back out? Hawking himself sat in a wheelchair, stared at the equations, and realized something terrifying. Black holes are not eternal. Hawking radiation. Virtual particles appear at the event horizon. One falls in, one escapes. The black hole loses energy. It shrinks. Over trillions of years, the black hole evaporates, slowly, quietly, dying. A monster that ate stars becomes nothing. But what remains of everything that fell inside? Scientists sit alone at their desks, hands on their heads. No answers. At the very end, a tiny flash of light, then nothing. Empty space. No trace. No tombstone. Just silence. And yet, a human face looks up at the night sky, awe and terror in their eyes, stars reflected in their pupils, walls covered in question marks, paradoxes pinned to corkboards, theories that lead nowhere, mathematics that breaks. We do not understand black holes, But we cannot stop looking, because if we understand them, we understand everything. Subscribe to Astralius. We look into the void, and the void looks back.